Greetings, the Astro 30 here again, and I'm going to move on to something else a little bit more constructive, or destructive as the case may be. I've got this little amplifier module here. It's a 2.1, that is a left and a right and a sub output channel, based on 3 TDA2030A monolithic power amplifier ICs, which are now discontinued, so they would most likely be Chinese knockoffs. And from what I can see in the bag here, I've got 3 potentiometer knobs. Yeah, so let's open up the kit and have a look at its contents. One heatsink, pre-drilled and pre-tapped. The potentiometers, the potentiometer knobs, some seal pads, and the screws, mounting hardware, and input jack. And we've looked bag of components with capacitors and terminal blocks for power input and speaker outputs on LEDs, some diodes, and the 3 TDA2030A chips. This is an extender cable because there's actually 2 PCBs, and there's a bunch of resistors in the bag here. There's 2 PCBs. This is the tone control board, which features, well, I'm not sure what that is, but it looks like some form of balance maybe. But I don't know if there's a volume control here or not. I can't see. There's no schematic, so I have no idea. But there's a single gang and 2 dual gangs. So I'm just wondering if one's bass, one's treble, and that I don't know what it does. Maybe it's the amount of bass sent to the sub output, so it's like a volume control on there. So there may not be actually a volume control before this. And of course the main PCB. Now, it's all fairly straightforward. The heatsink has a tapped set of holes here on the bottom, which will screw to the board like that when you're finished. So I'm going to assemble this. There's not much to it, so I'm going to, as I say, assemble it, and when I've assembled it we'll come back. Now, I've started with the control board, I suppose you'd call it, and well, just with mounting these header pins, which way around to mount it. If you notice, there's like 2 little dots here at either end of the pins here, which would line up with these little notches. So that's the way I'm going to put them around. It doesn't really matter as long as you get it round the same way, or the correct way, or I should say, yeah, the same way around on the other board. So at least it lines up. But they have marked with 2 little lines here inside the outer line where the 2 little notches for the connector go. So just keep that in mind. Okay, that's the control board built. That only took about 10-15 minutes. All the knobs are on and set to center for later testing, just in case we get no output and can't figure out why. And got the cable hooked up so I know where it is. So I can put that to the side now and move on to the main PCB. It uses an ANI 5532 op-amp IC, but they haven't supplied an IC socket to put said IC in, so you'd have to solder the IC directly to the board. Now, if you're concerned about soldering to ICs, which I am not, yeah, just go out and buy an 8-pin dual inline IC socket and yeah, install that to be done with it. It makes it easier changing the op amp to something else if you really want to. I'm just going to solder it straight in. So now I'm going to start with all the resistors, diodes. There's 2 or 1, I can see 3 large 10 ohm 1 watt resistors to install, which are here. So remember to install these slightly up off the board, and the same with the bridge rectifier over here, because these are 2 amp diodes. So it runs off AC, but I'm not exactly 100% sure what the input voltage was yet. I'll get back to you when I've actually ready to start testing. Got all the resistors installed, and I'm loving this tool. Thanks Peter Jansen for pointing this out to me. That resistor is a little bit proud, so I might fix him up. As I said, I've done all resistors but the 1 watt ones. I'm going to leave them till the very last minute because of how high they're going to be standing. So what I might do now is I might do these monolithic capacitors. I did end up with a spare 22k resistor over. I don't know where it goes. It goes nowhere apparently. So I've also got a 473 here which goes nowhere, so I've got a spare 473. I can't see where it goes on here, so they're giving me an extra one of those too. So I'm going to have parts left over. So if you have parts left over, don't worry, as long as all the holes are filled with what's supposed to be where it is, you haven't forgotten anything. Looking at this circuit, I reckon those large 1 watt resistors, 10 ohms, is for the Zobel network of each channel, because there's 3 channels and there's 3 10 watt resistors, 1 watt resistors rather. So, and they would be connected across some of these 104s or 0.1 microfarad capacitors, so that is a Zobel network. At least it's a relatively overcast day today, so I don't have sun beaming in here again like I did yesterday. Kind of makes the video kind of look washed out, which means I have to pull the blind down and add some extra lighting in here, which puts my power bill up for no apparent reason, just to shoot a video, right? It's like, yeah, okay, I'll pay for it, but still, I do prefer more natural lighting than anything else. But one day I am actually going to update my desk here and put some proper lighting in here so I can actually shoot video better. Maybe make a camera mount to mount up the top there somewhere. Okay, so that's the 104s, the 0.1 microfarads installed. Now, that was a floor jack, don't worry about that. Now it's a bit of a muchness as to what to move on to now. Well, I've got a bunch of these little connectors, so one would go here, one would go here. That looks like for OK power is what it says on the board, so I assume that that just goes somewhere off to an LED if you want. You'd obviously have to put it through a dropper resistor, but it'd be power out from here, and the negative is formed, well, the positive's coming off the 0 volt rail. So it is split rail supply. Oh yeah, I thought it was single-ended. No, it's split rail supply. And so this negative is coming off of, well, apparently nowhere on that side, which is interesting. Negative comes off the 0 volt, so where's the positive come off of? Nowhere. Well, that's interesting. I have no idea where that's coming from. It's just like an empty hole. It's no track on this side, and there's no track on this side. Okay, when all else fails, get the multimeter out, and I will just probe around somewhere. Okay, that goes nowhere. That goes to 0. Well, yeah. As I thought, this so-called positive goes nowhere. It's no track anywhere. I've just traced around where the LED is, and you know, and it's not giving me any continuity anywhere. It's not going to 0, or, well, that's going to 0, but this is not going to either the positive side over here. No, it's not coming off of one of these resistors. No. So that's kind of a pointless connection. So I really have no idea what it's for, and considering they didn't really supply me with any plugs for these type of connectors, I'm not going to use them. I'm just going to leave them off, because if at any time I want to put something on here I can, because we've got an OK SG, which I'm assuming means OK signal, but I'm not sure what you do with this OK power, so yeah, I'm just going to leave them empty, because, well, without a schematic I don't know what it does, but I will have to install this one obviously. So as I say, it's a bit of much of a muchness what to do now, where I install that or I install the 10 ohm resistors. Oh, I might install that first. Okay, that's installed. Just remember there's two little lines here and here on the PCB overlay, just inside the outline of the connector, which lines up with these two slots in the connector. Connect that round the wrong way and the front panel control board will not function correctly, if at all. Okay, I suppose I can move on to something else. Well, obviously I've got to move on to something else, otherwise it's not going to get done, is it? I might leave this 5532 IC till last, like all ICs. I really do need to connect these headers, but yeah, the jaws are in the way. So what I might do is I might turn this around 90 degrees, because I don't need to get to these connectors at the front here, because I'm not using them. So that'll allow me to hold the board. So now I can insert my connectors. I'm going to have to at least solder one in so I can get it to hold in still. So if I turn it upside down, it's not going to fall out. It doesn't matter if it's not quite taken in properly, as long as it's tacked in and prevents it from falling out, then that's all you need. And try and avoid touching the pin you're soldering, because you will burn yourself. Okay, so that's the general idea I'm doing there. Now for the next two along here. Now these should interlock to one another. So there's a little tongue here and a little groove here. So it's like a tongue and groove flooring really. You just put them together like that and it joins it into a four-way. So that gets put in there like that. And I give this the same treatment. I'm not so worried about that one falling out because the tongue will hold it in. This one I'll just tack this end in so it holds it still, if it so wants to. Yep, that's held in now. And finally the one at the opposite end, which is the left speaker output. So this one's going to be a little bit more challenging to get it to stay still whilst tacking one end in. Lucky it's not a very big board. Okay. Now I can go along and solder the rest of the connections in and then move on to another piece of the puzzle. Okay, now I'll move over to the 10 ohm resistors. Now don't forget to retouch up the joint that you tacked in the first place, just so it's a nice good joint. So just working out how I need to bend the leads here. Now, as I said, these are for the Zobel network, I believe, so they don't necessarily have to be close to the board, away from the board I mean, but I am going to put them slightly away by over bending the leads. By over bending I mean I'm bending them slightly beyond right angle so they just sit up proud from the board. And then that just is a simple matter of just soldering it from the other side. Okay, I know it might make it a bit harder to do the IC last, but I'm going to install the electrolytic capacitors. But obviously before I do that I should really install the diodes for the bridge rectifier over here. Again, I'm going to do the same thing. I'm going to leave them slightly higher than the board. There should be 4 of them and I can see 3. Oh no, there's the 4th one. Right, let's get to it. I was just installing electrolytic capacitors and I was looking around for the last 22 microfarad 25 volt because there's 6 of them. I found 5 large ones and then a little tiny one. So it is the same voltage rating and the same capacitance, it's just physically smaller. So it's just going to look kind of strange with the others there, but it is what it is. Anyhow, just remember to always get the polarity the correct way round, get the correct voltage rating in there. Don't do what I did the other day and have one blow up in my face. Okay, electrolytic's done, bar the two 4700 microfarad at 25 volts, and I've got yet another part left over, another 22 microfarad at 25 volts, which goes absolutely nowhere. So I've got 3 parts over. Must have been a different bill of material count or something, who knows. Now, I should probably think about installing the LED, the NE5532 IC, which I believe is for the subwoofer active filter, as well as the input connector, this phono input. Then I can move on to the 2 large capacitors. Then I am ready to move up to the TDA2030A ICs and heatsink. So yeah, I'll just do the LED, IC, input connector, and finally those 2 large filter caps, and we'll come right back. Okay, now if you're worried about soldering to these linear ICs or even digital ICs, it really makes no difference what you want to call them. Or what type they are, I should say. Through hole anyway. The idea is you do not want to have your dwell time too long. That's long enough. And by dwell time that means the amount of time you leave the heat on each pin. Another tip would be do one side of the IC, then move over to the other side, so you're not all soldering in the same line, if you get what I mean. So we just move back and forth, so we're distributing the heat through the IC evenly, and that should lessen the risk of damaging said IC. Also, having a pencil tip like this is absolutely paramount. But that's soldered in. I'm just not happy with those 2 connections there, so I'll just touch them up. That looks a bit better. And that is the 5532 IC installed. Next is these 2 large filters. Keep in mind orientation. So the little pattern line is the negative. And these are rated at 25 volt each, so your input voltage to this after DC rectification cannot exceed 20 volt. Just keep that in mind. Because the actual voltage requirements for this is 12 volt AC, so 24 volt center tapped, which would equate to roughly about 17.5 volts after DC rectification, and I'll calculate that in a minute and we can figure that out before we power this thing up and blow it sky high. I'm pretty sure the TDA2030 can handle a maximum of plus minus 20 volt anyway, so, but again I'll have to look that up on the data sheet. So construction is almost complete. Now all I've got to do is install this thing, which the clamp is in the way, so move him up. There we go. These got little locator clips on it to help it clip into the board so it won't fall out when it turns upside down. But for some reason the ground wasn't actually straight, the ground lead here, and it bent over on me. So always check your pins are straight first before pushing things in, because otherwise it's not going to go in, and then you wonder why when you look on the other side of the board there's no pin there to solder. So anyway, I'm going to start with holding that up a bit, start with the hardest one, which is the earth, because of all this copper to solder to, or put heat through I should say. And then do the left and right respectively. And that's almost the construction complete. I just have to now mount the ICs to the heatsink. And I'm not going to bother trimming those off. There we go. So this is actually designed obviously to mount into a speaker cabinet. These would stick out the front somewhere. But now to do the heatsink. Now what I would suggest doing is mount the devices loosely to the heatsink first, and I believe they're all the same IC, TDA2030A, TDA2030A, yep, okay. So to loosely mount the ICs, now they do give you isolation bushings, which you must use, but they don't give you screws to screw the heatsink to the PCB. So luckily I've got plenty of screws. So I take my screw and I pass it through the screw so that it looks like that, with the largest end facing the screw head. And then we grab the IC, put it in so that the smallest end goes through the tab like that. We place our sill pad on the heatsink and place both the IC and the screw up against the sill pad, and we just lightly tighten it. Don't over tighten it yet, we'll tighten it when it's actually on the board. And then we do the same thing for the other two. So now I bring in my circuit board, and if I could see what I was doing, you probably can't see what I'm doing, and I definitely can't see what I'm doing. I can feed each thing around. See, by the fact that I can move it around, I can actually line this last IC up a little bit easier. In fact, I don't really need that board plugged in at the... Jesus Christ. That is tight. Is there some kind of locking mechanism on that? No, it just looks like a normal plug to me. God, that's tight. Anyway, I'm waiting for some euphemisms in the comments section about that last statement. Yeah, this is awkward. I mean, considering I'm working in my own light here, I probably should put a light on now because it is getting pretty dull. I've added a bit more background lighting. That's one IC, that's two ICs, and this third one's legs want to be a pain in my ass. There we go, we have contact. Now, before I solder this, it'd probably be a good idea to screw it to the heatsink. So I'm just going to carefully place it down as to try and not let it fall out. And I'm going to grab two M3 5mm long, I think they are, or 6mm long, whichever, screws. Now that our heatsink is secured to the PCB, I can now go about tightening these screws, but I'm just going to adjust the sill pad underneath so that they're relatively straight, and then we can torque down the screw. Don't have to over tighten it, just tight enough to hold the device in place. Those capacitors are in the way. If I had one of those right angled screwdrivers, that would probably help me in this situation, but I don't. As I say, you don't need to over tighten these anyway, so if I can get just enough torque out of it to hold it, that's great. And then of course we just solder each of the leads on the bottom, and then the module is complete. So now the next thing to do will be connect it up to a power supply, but however we need 12 0 12. So what is that in DC? Okay, so we've got 12 volts, multiplied by 1.4, well, it's actually 1.414, so that gives us 16.9, so around about 17 volts DC. So 17, well, plus minus 17 would be the maximum you'd want to put into it. So I reckon for my testing purposes 16 volts should be pretty well adequate enough. Okay, got about 16 volt plus minus, which is 33, roughly 32 it should be. Hooked up to it. Load is off. I'm about ready to turn it on and watch the current draw. So here we go. We've got about 70 mA, which is quite considerable, and the little LED on the board has lit up. So now the next thing to do is, with the multimeter set to the DC range, is I'm just going to measure the DC offset on each output. Okay, so I'm going to measure the output of the right channel, I think it is. We have about 0.5 of a millivolt. The sub output, we've actually got 20 millivolt, and the left channel we've got 1.7, so we've got very little to no DC offset on the outputs, so that's alright. So I know that the output is working fine, so I suppose connecting it up to a dummy load on each channel and well, injecting a signal and see what we get. Okay, got the signal gen hooked up to the input. I've got the dummy load hooked across the right output for this particular setup at the moment. Just turn the load on. I've got it 1 volt per division, 1 volt peak to peak input, and well, we have precisely no output. Okay. Alright, well that's both perplexing and strange. Just see if this does anything. Oh, I'm getting something now, but I'm not sure what that is. We're getting next to no output, which I find awfully strange. Okay, well, I'll just change over to the left output. See maybe whether or not there's something strange going on here. Oh well, we have an output there, so we don't have an output on the right, but we have one on the left. Well, actually that means that this cable's back to front, because I'm actually connected to the ring, which is the right channel. See, it goes away again. And that is also the left channel, so why is it picking up on both? There's something funky about this cable. Okay, so I'm hooked up to the right channel and I finally got an output out of it. So what we've got here on the scope now is a peak to peak voltage of 5.51 volt, but that wouldn't be its maximum, so I'm going to have to up the amplitude until it starts to clip. Probably back off the voltage per division so I can see it. Currently we're at 2.9 volt input at the moment. Still no clipping. 4.6. It's starting to flatten at the bottom, so we'll call it there. We're at 4.4 volt peak to peak input. We're pushing out 23.93 volt peak to peak. These are supposed to be rated at 18 watts per channel, or per IC. So what did I say it was? 23.93 divided by 2 equals 11.965 times 11.965 squared, equals that divided by our load, which is 8 ohms. We are pushing, yeah, pretty close to the 18 watts, 17.8. So that's pretty good. There's none of this 18 watts at 10% total harmonic distortion crap. This is 18 watts before clipping. So that's pretty good. So that channel is working. So now I'll move over to the other channel. We get roughly the same amount of output, maybe a little bit distorted. There we go. So we're getting 24.94 there. I'm just going to do a quick calculation. And according to my calculation later, it's about 19.4 watts. So that channel is working. So what we need to know now is what the RMS value would be. So the VRMS is 9.12. Well, we did that calculation before. 9.12 times 9.12, that's squared, equals 83, divided by our load, 10 watts RMS. So it's 10 watts RMS, around about 18 watts maximum peak. So that's pretty good. Now to test the sub output. We're getting a peak to peak voltage of 18.65 there, but let's see what happens when I rotate a control. Not too much change. That seems to increase it even further. So we're getting 23.32, so we're getting close to 18 watts with one of those controls at maximum. So now what I need to do is hook this up to some speakers. First, I don't have anything to hook up to the sub, but I want to find out what all these controls do, you know. So I'll just turn the load off and do a heat test, and that heat sink is red hot. So yeah. And that's only driving one channel. Now, with all three driven, that's going to be boiling. That heatsink's way too small, in my opinion. But yeah, well, it is what it is. I would suggest putting it on a bigger heatsink. Alrighty, you got them hooked up to the bookshelf speakers on the desk here, so I'm just going to power it on. A little bit of a thump. Got noise coming out the left, noise coming out the left, which is interesting. It should be coming out the right. I don't understand why it's coming out both the left and the right in mono. That really makes absolutely no sense. Alright, gonna see what it sounds like with music coming out of it. I have not much going on the right. This is a blend control. This is strange. That's a treble. That does. But we've got no right output. This is the weirdest thing I've ever seen. If you plug the right into it, it comes out the left as well, louder. This doesn't make sense, because that's not stereo as far as I'm concerned. Yeah, I'll hook that up to the sub and it's actually oscillating. Yeah, that's really going to work well, guys. So I'll get rid of that, and I will hook up this desktop one, and it's definitely oscillating. So this thing is absolutely useless. It's a piece of shit. It's been assembled correctly, but I'm getting both left and right channels mixed in together, and yeah, I'm not happy with that. I mean, I only paid like $11 for it, but that's not the point. You expect the fucking thing to work properly when you construct it. I haven't done anything wrong. It's all fucking hooked up the way it should be, but no, it's just a total failure. The sub output is oscillating, or motorboating would be another adequate description for that. And I'm not even getting a stereo image coming out of it. Very little coming out on the right, and mixed left. So I don't know whether it's a design thing or something, but yeah, the thing is a piece of shit. My recommendation, I wouldn't even bother. These TDA2030A ICs are obsolete anyway. So there's the eBay item. I'll put a link in the description for you if you want to buy it. I wouldn't. I only bought it just to see what it was all about. And it does say a lie. It says audio amplifier board, subwoofer amplifier board for Bluetooth 2.1. There's no Bluetooth chipset on the thing, and yeah, so it's a lie. But its output power is pretty close on. It's 18 plus 18, 4 to 8 ohms, 15 to 50 watt full range speaker. So yeah, its description's pretty accurate. You need roughly a 30 watt 2 amp power supply or transformer to power it, but yeah, as to why this thing is oscillating, I really have no idea. Yeah, without a schematic, I can't actually go ahead and fault find the thing. And I really wish the Chinese say, oh, no schematic, no need for schematic, you just follow board layout and put parts in me, sucky $5. Yeah, unfortunately, I'm sorry, but that's not good enough. Most of us who assemble shit like this want the schematic, and I'm telling you right now, I definitely want the schematic, because I want to see how this thing is actually configured, and then go through the circuit board and see if I've made a mistake maybe with this cable, because I was only following what was on the silk screen, and I could have inadvertently hooked it up backwards, who knows, but getting it back out now would prove to be a bastard. But yeah, the schematic would have helped. But no, there's no schematic. So what do I think of this thing? Well, it's a piece of shit. That's what I think of it. So this has been a total unsuccessful waste of a day, doing jack shit basically, and achieving nothing. This thing is crap, and there's quite a bit of buzz coming out of the speaker too. I'm not sure what's going on with the audio input here. Could be anything. So as for the thing oscillating on the sub output, it could be one of those TDA devices, or so-called counterfeit devices, are actually, or is actually I should say, not functioning correctly. All the resistors and capacitors are in the right holes, etc., where they should be according to the overlay. So as to why it's oscillating, I don't know, but as I said, a schematic would help, but I don't have one. I mean, even that amplifier that I built the other day with the buzz in it sounds a hell of a lot better on that same track than that piece of junk down there does. I don't know. Okay, I never let anything get me down. A short time later I've disconnected the tone control board. and found that there is now no oscillation on the sub output. I connected this right speaker onto it and it was working fine. Very low in volume, but it was working fine. Now if I touch the tops of one of each of these capacitors, start over here, that's the left channel at full volume, and there's the right channel at full volume. So that means more than likely that this connector is wired backwards on one of these boards, which means I'm going to try and take this connector off and turn it 180 degrees around, because this should be, by rights, the bass control. That should be treble and that should be a volume control. But it was doing something volume wise over here but acting like a balance, and that's not correct. That should be a bass control. So that means I'm going to have to turn this connector around. Well, it's worth a try. If I'm getting output from both channels separately by touching each input capacitor, then, well, it's basically passing through here, so it shouldn't be any different. So, okay, time to change that connector. Okay, got that connector turned around 180 degrees. It wasn't as hard as I thought it was. It only took me about 10 minutes to get the stupid thing off. But, okay, let's try it now and see if there is a difference. Alright, now I've only just got the left channel connected for now. Whoa. That was a nasty noise. That's why, because the power supply was shorting. Ha! Always check that. At least it sounds like it's in stereo, and I'm not sure what that does. That's treble. Well, it sounds like it's in stereo now. It sounds distorted as hell. Well, distorted on the right anyway. Left sounds alright. Right sounds distorted. Jesus. Yeah, that sounds like absolute shit. Not exactly. I'm still not exactly happy. That right channel's distorted. And listen to the amount of noise the thing's picking up. This is not quiet at all. It's still a piece of shit. Regardless of which way around you insert that socket, that connector, it's crap. The right's distorted, and yeah, frankly, I wouldn't buy it. If it, that's my recommendation for this whole video, is don't buy it. You're wasting your time. You're going to be disappointed with the results. It shouldn't be that noisy. Well, it is on there for some reason. So as soon as it's plugged into a source, it's noisy as shit. It's quiet when you unplug it. These are backwards. But I can hear on that channel there is no bottom end. There is on that one. None on that one. Well, that now would be because I've fucking blown that driver. So this thing is now fucked. Okay, well, fuck this shit. I've had a fucking enough of Chinese shit. Fucking really had enough. Yeah, it's damaged. But the ring that was around it, this plastic thing, does come off, so I can actually get the driver out. It's sounding pretty distorted now. I just did the sniff test in there. It smells like burnt electronics. I think I've done the voice coil. Now, it doesn't actually say on here how many watts it is. Doesn't really say anything that valid. So I'm going to have to find some 100mm drivers. Probably mid-range speakers will do. It's got a fairly large magnet on it. So I'll see if I can find a replacement driver. Oh well. Thanks for watching. I'm the Astro 30, and as always, if you like this video, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyways, this is the Astro 30 saying, see ya, have a great day, and I'm not your Darlington.